Why are fractals found everywhere in nature? Have you ever noticed how nature seems to repeat patterns over and over again? This fascinating phenomenon is called fractals. But why are fractals so common in the natural world? Let's take a closer look at this captivating topic. Fractals are geometric patterns that repeat themselves at different scales. This means that smaller parts of a fractal resemble the whole. This property is known as self-similarity. It allows nature to create complex shapes through simple, repeated processes. One of the most basic examples of fractals is how many natural objects grow by branching or spiraling. Think about a tree. It starts with a main trunk that splits into smaller branches and twigs, each one looking like a mini version of the tree itself. This branching pattern is efficient because it maximizes the tree's exposure to sunlight and air, which helps it thrive. The human body also showcases fractal patterns. Our circulatory and respiratory systems branch out repeatedly, forming networks that efficiently deliver oxygen and nutrients throughout our bodies. Plants are another great example. Many plants grow in spirals that follow the Fibonacci sequence, a series of numbers that creates the golden spiral. This arrangement helps them pack leaves or seeds closely while still capturing as much light as possible. A perfect illustration of this is Romanesco broccoli, which has cone-like buds arranged in a fractal spiral that repeats at smaller scales. You can find fractals in many other natural forms too. Ferns have leaflets that are tiny copies of the entire frond. Coastlines, mountain ranges, river systems, clouds, lightning, and snowflakes all display fractal patterns. These patterns arise because they provide efficient ways to fill space, distribute resources, or respond to environmental forces. For instance, coastlines are shaped by erosion, creating complex, self-similar shapes at various scales. From a numerical perspective, fractals reveal how simple mathematical rules can lead to the rich complexity we see in nature. They show that nature often uses repeating patterns to build structures that are both beautiful and functional. By understanding fractals, we connect with the numerical patterns that underlie life, illustrating how mathematics is woven into the forms and processes around us. Recognizing fractals in nature can be beneficial in various fields, including ecology, medicine, and computer graphics. For example, modeling blood vessel branching as fractals can improve medical imaging. In digital art, fractal algorithms help create realistic landscapes. So, the next time you look at a tree, a fern, or even a snowflake, remember that these beautiful forms are not just random. They are part of a fascinating world of numbers and patterns that help explain how nature works. Fractals are everywhere, and they reminded us of the incredible connection between mathematics and the natural world.